Hello scholars, welcome. Mr. Hinkle here, talking about organisms that live in the open ocean, the pelagic environment. And these organisms can do one of two things. They can float or they can swim. And if they swim, they're called marine nekton, which is the topic of our lecture. Our objective: describe marine nekton organisms and provide examples of the biodiversity and some of the marine adaptations. The theme of marine life is that there are different types of marine life that live in various habitats that have adapted to these environments. And so the environment we're talking about is the open ocean, and in specifically here, nekton, which are marine swimmers, or more technically, the ability to propel themselves through the water column. They might have powerful tails or certain appendages. There's mechanisms for buoyancy to help prevent them from sinking. And we get diversity that comes in these general groups of organisms, including squid, fish, reptiles, marine mammals, and crustaceans. Let's go over some of these nekton species. Squid. Very common. So we have common squid, flying squid that can actually propel themselves and shoot out above the water column, and then giant squid, which live in the deep ocean environment. Really cool. We've never actually seen a giant squid alive. We know that they exist because when they die, they might float up and wash onto a beach, and then we get to discover them and study them. But these monsters, these giants of the deep ocean, still remain a mystery. And squid are cool. They prey on fish, and they actually will take in water and then expel the water for propulsion. So this is their method of swimming. This is their adaptation for surviving in the open ocean as a swimming organism. Fish, maybe something you and I know quite well. Fish are cool. You may or may not choose to eat fish, but there's a lot of fish in the ocean, over 22,000 species. Fish have a bunch of different fins for propulsion to make their way around. They have a swim bladder that is a pocket of gas that can expand for them to float and contract for them to sink. And then they also have what's called the lateral line, which is an area that senses changes in water pressure so that they can identify their surroundings, allowing them to be sensitive and mindful about the environment for both protection and feeding. Fish do all kinds of things. They school, they can avoid prey, they can search for prey. Fish are really cool. I like fish. Reptiles. Whoa. Reptiles are dinosaurs. They look like dinosaurs. The age of the dinosaurs could actually be considered the age of reptiles. We are in the age of mammals, where mammals are the dominant species. That's what you and I are on this earth. But here we've got crocodiles, iguanas, sea turtles, and sea snakes. Alfred Wegener's evidence when he developed the theory of continental drift was looking at marine reptiles. There's over 100 species, so the diversity isn't tremendous, but still, remnants from an age of the past with unique adaptations. Marine mammals. This is the subject of another lecture, but just to introduce, marine mammals have land-dwelling ancestors. It's such a cool story where organisms in the ocean, vertebrate animals, evolved to move onto land, and then they said, you know what, I want to go back in the ocean. They went back in the ocean, and then further species diversification led to 3 orders: Cetacea, Carnivora, and Sirenia, giving us various types of marine mammals. Please see my next lecture. I'll go more in depth on that one. And then we've got crustaceans, which are going to be not as numerous because most marine nekton are vertebrate animals, but we also have invertebrate animals. That's why pelagic animals is a little bit more inclusive than saying invertebrates of the marine environment and vertebrates of the marine environment. But we have arthropods that can swim, shrimps, prawns, these types of animals. So crustaceans is another group of swimmers in the ocean. And then, of course, you have fish that live in the deep ocean, deep sea nekton, that survive in areas where there is no light, the bathypelagic, the abyssopelagic, and specific adaptations here are large eyes. And then also they can illuminate their environment for protection and also for feeding. It's called bioluminescence. These organisms will also feed on the decaying matter that rains down from the upper water column, where most of the primary productivity in the oceans is occurring. So nekton are marine life that swim in the open ocean. They're a diverse group of pelagic animals with a series of marine adaptations for the varying environments in which they live. Thank you so much, and I will see you again.